Okay, 8th graders, today you have a video lesson. So the objective is solving OR type compound inequalities. What I want you to do is watch the video, and then when after I get to something, pause it and write the stuff down. Don't pause it right now and write down everything because you won't pay attention as much, okay? So you need to do it along as I do it. All right, in the last lesson we solved AND type inequalities. And I told you if it's less than, we say less than, and it helps us remember, and it would be open circles with our solution in the middle. Less than or equal to. Okay, we remember the symbols and how we use them as the clues. We use bad spelling. Okay, so less than tells us it's going to look like this. Today's clues, well, we're going to actually, it says the word or in the middle of it, but greater, okay? And that would be an open circle going one way or the other way. Greater or equal to, we open closed circle going either way. And you can also think of the arrows as oars, another spelling for or, on a rowboat with the boat in the middle. So like your boat could be here, and you could be in here with your rowing the boat, okay? So you could be here, and you could be rowing the boat. Yay! All right, how to write a compound inequality from a sentence or a graph. So you're given a graph, and it looks like this, and notice we only have 2 points on it. We always start with the x first. So this one we would say x, and it's going to the left, less than, because it's not colored in, it's not less than or equal to, -3. Remember, you can use the directional arrow to tell us which way we're going. Or, we have to write the word, x is, which way is this one going? To the right, greater than 2. That's it. It's pretty easy. Here we would have another one. This one would be x is, hopefully you thought, less than or equal to 6, or x is greater than or equal to 8. All right, here it is, a sentence, and you need to translate it. All real numbers less than -7 or greater than 13. So we just say x is less than -7. You always have to write this word, don't forget it. Or x is greater than 13. How about this one? All real numbers less than or equal to 5 or greater than 17. So all real numbers is our x, less than or equal to 5, or all real numbers greater than 17. So it's pretty simple. Okay, all of them today are going to have the word or in the middle, and they'll be graphed as if you could make a boat with you in the middle at the oars. So you can also solve the inequalities, then graph them. We don't always just give them to you ready to go. So here's an example. D minus 4 is greater than 3, or, here's your big clue that it's an or, D minus 4 is less than or equal to 1. Here are your steps. There are always 2 inequalities in the OR type problem, so you just need to remember that. So you solve each one and then graph it on a number line. So on this one, I'm going to add 4 to both sides, get D is greater than 7, write the word OR, again add 4 to both sides. Now they don't always say add the same thing, this one just happens to, and get D is less than or equal to 5. So notice the numbers may not be in the number line order, like 5, you know, this is pointing to the left, so 5, and then this is pointing to the right for 7, but it doesn't matter, just graph them as they are. So you draw your number line, you just need to put your 2 solutions on it, you don't need any other numbers, and then do what it says, greater than 7. So is that an open or a closed circle? Open, and it goes to the left. Less than or equal to 5, open or closed circle. Hopefully you said closed, and it goes to the right. Notice once again we always have our variable on the left in these solutions, because then we can use the inequality symbol as a directional arrow. All right, 2 more. Here we have 3n minus 11 is greater than or equal to 13, or -3n is greater than or equal to 15. Now you notice they're both going the same direction. But We're going to be dividing by a negative, so that will change something. So let's solve this one. We'll add 11 to both sides and get 3n is greater than or equal to 24. Divide both sides of the equation, inequality, by 3. N is greater than or equal to 8. Or, don't forget to write that word, divide both sides of the inequality by negative 3. And now since we're dividing by a negative, remember you have to change the direction of the inequality. Here it was greater than, now it's less than. N is less than negative 5. So on our number line, we only have to put the two solutions, 8 and negative 5. N is greater than or equal to 8 is a closed circle, and it goes this way to the right. Less than or equal to another closed circle, and it goes to the left. When we're doing these problems, they can both have the same, open or closed circle, or they can be different. All right, here's another one. Negative 1 plus x is less than or equal to negative 3, or negative x is less than or equal to negative 4. Once again, if they're both pointing in the same direction, something's going to have to change 99% of the time. So let's solve this. Add 1 to both sides. X is less than or equal to negative 2. Divide by negative 1 on both sides, because remember there's an invisible 1 in between there. And we get x is greater than or equal to 4. So here's my closed circle. There's also my cell phone ringing. And here's another closed circle. Okay, and that's it. Now, rarely you may get a problem where both are greater than or both are less than. Okay, so like for instance, if this wasn't divided by a negative and we didn't change the direction, then you only have one ray as your answer. Because remember, these are technically rays, because one endpoint in direction. So x is less than 5 or x is less than 10. Well, if we graphed this, it would go like that. But then if I graph this one, it overrides everything. So it just ends up with 1, and the 5 is taken care of with this. Doesn't happen that often, but it does happen occasionally. All right, that's it.